Hello, community. Imagine you have a surveillance situation and you need to determine which object is where in relation to which other objects. This is what we're going to talk about today. So, intelligence gathering is of extreme importance in the exploration of the environment. You can send patrols, you can go scouting, and you have surveying. And this goes here for maps, aerial photography, satellite imagery, drone technology. You need to know what's going on in an urban area. You need to know what's going on in an area, maybe somewhere in a foreign country. So here we go. As you can see here in 2019, posted here, end of August 2019, the Air Force, the US Air Force Research Laboratory, over DARPA, the Defense Advanced Research Project Agency, awarded here a specific contract to IBM. The contract was rather not really important. It was just about learning automatic, transfer enhanced, and relation aware labels. And you might say, what? $3.6 million for labels? Yes, but they are very specific labels. Have a look at this. End of August 2023, we get here a preprint. A preprint exactly by Rice University, MIT, IBM Watson AI Lab, MIT, Georgia Institute of Technology, Weizmann Institute of Science, and IBM Research. And they have, and referring here to the DARPA contract, they say, hey, we can go beyond nouns with vision and language model using synthetic data. And you might say, hey, great, interesting, but what is the relation here to our topic? Well, look, what they are doing is here, they create synthetic humans in different scenes with different camera angles in different surroundings, like for a civilian house, or maybe it is an urban street, or maybe some other area. And they say, hey, we can put here a suitcase. And you might say, does the suitcase belong there? What is the position of the humans in relation to the suitcase? Are they friendly humans? Are they humans that are behaving strangely? And so Air Force said, hey, generate videos to track human-object interactions. What are humans doing in relation to object on a ground in a city somewhere else? Identify the person, describe the person. And the description is rather precise. Have a look at this. Amazing. They really go, the car tire is left of the human, the stool is in front of the car tire, the human is to the right of the microwave, and you can simply ask, hey, is this okay if a microwave is standing in the middle of the road, or any other object the Air Force might be interested in is standing in the middle of the road? Give me a complete intelligence gathering of the situation. And let's say here you have some autonomous drones, and let's say here we have no communication facilities in the area, so there's no data uplink of your data. So maybe some autonomous drones or other vehicles have to make decisions about themselves. So you get an idea where we are talking about. Great. Now, the goal here of this contract was to create a synthetic text image dataset. What does this mean? Simply, do you have an image and you need the text describing exactly the content of the image, because this should be a training data set for a vision language AI system. You know, language system or LLMs like ChatGPT or GPT-4 or any other system, and you know vision system, vision transformer system. And if you combine them, you need a lot of training data sets, so that in a specific non-civilian situation, maybe, the Air Force is interesting to have a complete surveillance, a complete reconnaissance of the complete system. But please note that here robotic or autonomous drone systems are explicitly not mentioned in the civil version of this research paper. So what they did, IBM created here with its partner some synthetic visual concepts, a dataset of more than 700,000 image text pairs. As I showed you, an image and a really detailed explanation of what is going on. So how do you create, even you have 4 years and 3.5 million, how do you create over 700,000 precisely labeled image text pairs for your particular task? Yeah, easy. You create synthetic videos, and I will show you in a second. And in these videos, let's say close to 2000 videos, you sample then image text pairs for a particular situation. If a person is standing in front of an object, right next to an object, is interacting with an object, or two persons are interacting with each other, or whatever situation. So you create synthetic videos and you just sample them here, image text pairs. How you do this? Well, this is a really interesting way of doing it. And then they had about close to 200,000 individual, very specific situations where synthetic scenes that they labeled. And as you can see here, they went here with an abstract figure of a human. They interestingly decide to have here a clear difference between a male and a female person. So think about here a woman, I don't know, let's say in this demonstration you see that the woman has nothing in her hands, but let's say a woman carries a baby in her arms. So let's say a man also officially carries nothing but carries something in his arm. You might guess what. So you can even go here with the garment. What is the clothing? Is it specific to the region? Think about you have here some situation in a desert environment. People are maybe dressed in a different way. Maybe you're in, I don't know, a European environment. People are dressed in a particular way. So interestingly, in the Air Force contract here, the clothing and maybe the things that the persons are handling or carrying, you could go to a level to have really a perfect description here, which is interesting. Now you might say, how is this possible that we generate here close to 800,000 specific, highly detailed here text image description for autonomous systems? Well, 3 steps. Let's start with the first one. You define the scene. And I mean, really, you define the scene. You say, hey, I have a sample scene. Let's say the interior of a civilian home or a city street or some other region, somewhere in the world. You say, I have a lot of different camera angles from the ground, from the drone level, from satellite, or whatever you can think of. And then you have objects. And these objects are somewhere in the scene and they interact in different ways. And those objects have attributes and you create them synthetically. And then you have here an action sequence in your video. And you might ask how we do this. Well, you just take a game engine, Unity, why not? Whatever you have available. And then you feed in your digital humans that maybe have some particular garment, carry some particular objects, are interacting maybe with each other or maybe not friendly interacting with something else. And then you feed this information in and you build your scenes. And then you have, let's say, a simple game engine. And as you can see here, this is the civilian version. And you create here now a very specific situation. And since you defined here the situation, and in 2019 there was not possible to have ChatGPT, so they really coded this. You see here the positional relations, and they say here, yeah, left, right, front, back. Left is to the left of a specific object, or this object is to the right of a specific object. So the relation handling is important. Or here they have closing and action. Is this a friendly action or is it maybe an unfriendly action? And with the closing, what are they wearing? Are they specific to a specific region, a specific, let's say maybe a uniform? You know what are the theoretical possibilities. And then if you define the scene, you create the scene, you can record the scene. And since you defined here the scene, you know exactly what the caption is. So you can use here an AI system, a simple AI system, give them all the definition here of the scene. Then you have here from, let's say, a game engine created, you have here a street. And on the street, there is something on the street, let's say a package or a suitcase. And you have 2 men, and maybe you're interested, hey, does this suitcase belong in the middle of the street? Or is this a situation I should take care of? And you see here civilian description, and notice how clearly this is defined. Look, the first human is walking. The first human wears a red shirt and solid black pants. The first human has brown hair. The second human stands straight. The second human has brown hair. The second human is wearing blue jean pants, brown shoes, and a white shirt. So whatever is published here in this version, I have to say, this is a very, very specific, detailed description of the scene. So if you have now this 2000 videos with different kind of interactions, civilian or maybe not civilian for the Air Force, you can imagine what this dataset include or might theoretically include, what kind of situational awareness you like to judge here an autonomous system to make decision. And then of course you have the standard AI models that you interact with. But what you have created is a unique dataset, maybe just 2000 videos, but you have here some extreme detailed text image description data that are essential for training your system, and they call it a synthetic visual concept that they created. And now please think about this. This contract was awarded by the Air Force in 2019, 4 years ago. And today in the civilian AI research, we would need those data sets because, as you see, the value of this data set in 2019 was $3.6 million. And since we have an archive publication, you're saying, hey, great. And they say, hey, we released the code together with the synthetic data set. And I said, wow, great. What a precious information we have here. And then you go here to the GitHub repo and you say, yeah, the data set and the data and the algorithm are coming soon. We only have a README file over there. So maybe it's gonna take some time for the civilian version to be released. Interestingly, and this is here the last information I would like to give you, they are also here, CLIP I showed you here on our vision transformer, our language model, our stable diffusion. CLIP is really a system that almost everybody uses, and they says, hey, at first they compared it to CLIP and they said, hey, it's better, and they even have here an application where they mention blip. Now, if you are not familiar with blip, I have here 2 videos for you where you have, for example, here vision transformer. And I showed you that here blip connects here with a U-former, the vision language model here in a particular way. So we have here vision transformer. And as I did the video 6 months ago, I still had to use a T5 LLM. Maybe today I would use ChatGPT or any derivation of this system or any LLM that you like to have. So you see that they mention here blip. So this is some interesting application we can read out here of this particular preprint. Scientific preprint is about research. And if you're interested a little bit more about blip, I show you here the code. I code here together with you a vision transformer and here a chat LLM. I choose at the time of the recording 6 months ago a FLAN T5 transformer model. So you see here that we need a lot of training data sets. I, of course, did not have access to this training data set, but I already tried to indicate what would be a theoretical application if you want to identify specific object or specific vehicles or specific whatever with a variety of sensor, with a visual sensor, with an infrared sensor, with a night sensor, with whatever sensor telemetry you can have from ground, air, or orbit. You can combine this and you can gather intelligence. And intelligence from urban areas to some other region is one of the most important facts to make any decisions. So this was it for this video today. I hope it was informative. I hope you got some ideas from this video how some organizations will use here vision transformers and LLM in a combination and have here maybe some robotic components. I say thank you for watching, thank you for listening. Would be great to see you in my next video.